Alright, so we are starting chapter 9. Chapter 9 is probably going to take us 2 weeks, so we don't have a quiz this week. I don't think we even have a quiz next week. Okay, we have about 2 full weeks until we take an assessment on this. Okay, a lot of moving parts. The math itself is not too hard. We just need to make sure we know what we're doing. So, a system of equations, right? A system is like our car is a system, right? The school has a system. It's a bunch of parts that work together. And that's what a system is in math. It's when we have 2 or more equations that have the same variables. So all of our problems are going to have 2 equations in there. Here's an example of what that looks like, right here. This is all one problem. Okay? We use this bracket to represent, hey, this is the whole problem. Our problem is made up of 2 equations. Okay? So this is what makes it a system. It's made up of more than one equation, and both of these equations have y and x in it. Okay? Now, the solution to a system is where the lines intersect. Most important part of everything we do. Your solution is where the 2 equations are equal to each other. And on a graph, that means it's where the lines cross. Your goal is figuring out where do our lines intersect, cross, merge, touch each other. That's the goal. Okay? So here are our 2 equations. Here is a graph of our 2 equations. Okay. Part 1 just asks us which point represents the solutions, or the line, y equals x plus 3. So is blue or red, y equals x plus 3? We could type it into Desmos, or we could figure out which one crosses at 3. Which one's crossing at x equals 3, or y equals 3? Blue or red? Isn't it the blue? See how the blue goes through 3? Okay, so A, this is our blue. Okay, this is the blue line. Which means 2x plus 2 must be our red line. What? For what? What about it? Oh yeah, you can take it today. Okay, so remember our solution is where the lines intersect. So go ahead and put a big fat dot on the point where your 2 lines, red and blue, intersect. Where do they intersect? Put a big old blob. And this is the whole idea of everything we're doing, is finding the point where they intersect. That's the goal. A big flat blob. So, is this the point where you said they intersect? Yes? No? Maybe so?
Oh, I got 2.
And this is the point 1, 4. That is the solution. That is how you solve a system. Finding the point where they intersect. Now, sometimes they're not going to give us the graph, and that's why we use Desmos. Desmos is going to help us graph it and find the point where they intersect. That is the goal. Where do they intersect? Where do they intersect? That is the goal of these problems. Okay, where do they cross? Where are they equal? There's always one point where they cross. That's your answer. Okay, if we wanted to check our solution, we'd plug in 1 in for x over here and make sure they equal each other. If we plug in 1, 1 plus 3 is 4. If we plug in 1, 2 times 1 plus 2 is also 4. They both equal 4 at 1, so that's the answer. Okay, so let's do it. Let's do it. Okay, so right below, do you see how we have 3 possibilities? When we solve this problem, there are 3 possible scenarios. These are the only 3 things that can happen. It will always be one of these 3. Scenario 1 is the most common. Do you see our 2 lines? And do we see that they intersect? See them intersecting right here? The first scenario is our system has one solution. One solution. This is the most common. There is only one spot where these 2 lines intersect, and they'll never intersect again. The second scenario. What is happening in the second scenario? Why is the line purple? Guess how many lines are actually there? 2. We have a red line and a blue line right on top of each other. For the exact same line. And if 2 lines are on top of each other, how many times are they touching? Are they intersecting? Infinitely. They're touching and intersecting everywhere, which means we have infinite. There are infinitely many solutions. Does it happen often? No, but it does happen. The last scenario is when our 2 lines are, what's the word for that? Parallel. No matter how long we extend these lines to the left or to the right, because they are parallel, will they ever cross? They'll never intersect. So does this system have any solutions? No solutions. These are the 3 possibilities when we start doing these problems. Yep. There is either going to be one point made up of an x and y value. They will either be the exact same lines and have infinite solutions, or they will have no solutions. These are the only 3 possible answers any of these problems can have.
One, none, or all.
One, none, or all. Okay. Now it's time to do it, and this is where Desmos is super important. Problem number 1 through 4. Let's do it. And I cannot stress, if you don't have your computer today, that is okay. I did not remind you, and it was a long weekend. I understand. But it is very, very important that you do start bringing your laptop here, or your Chromebook the next couple weeks. All right. We are going to graph each one of our solutions, or our systems, and we are going to determine the solution, or infinite solutions, or no solutions, because remember, those are our 3 possibilities. So I'm going to pull up Desmos. I'm going to clear out what I had before, because I don't really need it anymore. And I'm going to start with my top left box. Okay, so the first thing we should do is we should type in our system. In 2 separate lines, we're going to type in our 2 equations. Y equals 2x plus 7. In my next line, my second equation in my system. Y equals negative x plus 5. Mine are blue and green. So here are my 2 equations in my system. Our solution is where our lines do what? Intersect. Okay? So, if you did it right, you will see a point that shows up gray. Okay? You will find a point that shows up gray. that is the point where our solution is. Now, I chose a problem like this because if you remember back when we were doing linear lines, when we got a gross nasty number like this, what did we do? Remember what we plugged into Desmos? So if I want to plug this in, negative 0.6 repeating, remember, negative 0 point tons of sixes, and then I click our button. That's negative 2/3. Our y value is 5.6 repeating. 5 point tons of sixes. Click my fraction button. And that's how I get my solution. You remember doing that? The repeating number, turning them into fractions. Okay, so our solution is at negative 2/3 and 17/3. This is where our two lines intersect. This is where our two lines intersect. We should also make sure that we are sketching the graphs. Again, they don't have to be perfect, but here like negative 3.57. Here I have the points 5 and 5. I should be at least doing my best. 1, 2, 3.5. 1, 2, 3, 4, 5, 6, 7. And I had 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Doing my best to sketch each of my graphs. Okay? Because sometimes on the OST, you've seen those questions where they have you like click the points and drag them to put the lines on the graph. So it's a good time to practice that. Okay, we're going to do one more together. I'm going to do the bottom left one. Okay, again, you can always click the gear and delete all. And we do the next one. Okay, so here's my system. I have two equations in it. I'm going to type both of them in. 3x minus y equals negative 4. And y equals 3x minus 5. I'm going to take a look at my system. Now, right off the bat, what do you notice about our red and our blue line?
They're like parallel.
They're parallel, right? I should always double check and just zoom out a little bit and make sure they're definitely parallel, because you want to be careful. Sometimes you might be really zoomed in like this and it looks parallel, but when you zoom out, they do eventually cross. But this one definitely, no matter how much I zoom out, is it ever going to cross? No. I mean, if I go really far out, it looks like it's crossing, but it's not. So just double check, make sure you do a little zooming out, a little bit of zooming in. But these are definitely parallel. And what happens when we have parallel lines? There's no solutions. There's no place where the equations are equal. There's no place where our equations will cross. Again,
You know why parallel lines are sad?
why are they sad?
Because they're so close but they never meet.
So close, but they never meet. Again, we should do our best to draw a little sketch. Okay? It does not have to be a perfect sketch, but just enough so that you can get an idea that, hey, these are parallel, which means no solution.
By the way, guys, just as a kind of an observation, would you agree that parallel lines have the exact same slope? Because if they're both going up in the exact same way and they never cross, that means the slope, the rise, has to be identical. You guys will learn about that in depth.
Okay? Take some time and seriously try these next two all by yourself. Okay? Try them all by yourself. Okay? If you you need to make sure you know how to plug them in. You need to make sure you know where to click around and you're not just watching me do it. Okay, because there is a big difference.